Assalamu alaikum wa rahmatullah. I will continue the part on quadric surfaces. Okay, so in the last class we did the first graph, which is an elliptic paraboloid, and the equation is z equals x squared over a squared plus y squared over b squared, and this is the general graph. Okay, I did this in detail using the trace method. Okay, and this is what we get. Okay, we have now five other classes. Okay, five other surfaces. Okay, so I will not do the detail, but I will give you the form of the equation, the name, and the graph, the general graph, with a little explanation, so that you that will help you memorize these graphs. Okay, so we started with this equation: z equals x squared over a squared, y squared over b squared. Okay, now the next two are the following, so just pay attention. The next two are the following. I have z equals x squared over y squared over a squared plus y squared over b squared. Okay, and the third one is the same thing, 3 z equals x squared over a squared plus y squared over b squared. Okay, so notice just the main objective is to help you memorize these. Okay, so notice I'm using the same equation, in number 2, number 3. Okay, in fact they are not all the same, but there are some variations. So this is the original one. The second one, it will be the same, except the middle sign will be negative. Okay, negative. Or let me say, it can be written z equals y squared over b squared minus x squared over a squared. Okay, so this is the next graph. Okay, the next graph, or the next step. It is the same, except you have negative here. Okay, now what is the name of the surface? Okay, just remember, really we said for number 1 elliptic paraboloid, the name comes from traces. The traces are ellipses or parabolas. So here, what are the traces? Okay, if y equal to 0, هتكون z equals x equal over s equals a parabola. If x equal to 0, you get a parabola also. If z equals a constant, a number, you get a hyperbola. So the traces will be hyperbolas and parabolas. Okay, so we call it hyperbolic paraboloid, hyperbolic paraboloids. Because the traces are hyperbolas or parabolas. Okay, this is the name. This is the reason for the name. Okay, what is the graph of this one? Among the 6 surfaces, this is the hardest to graph. Okay, so it is better to see the graph in the textbook. Okay, so I will leave the graph for you to the textbook. We'll see the textbook. Okay, the general graph is like a surge of a horse. Okay, a saddle of a horse, مثل سرج الحصان, زي سرج الحصان. Okay, so it is like a saddle of a horse. Okay, so this is at least the name, and this is the form. This is the name and this is the form. Okay, the third class, again, the equation is the same as the original one. Now this is the first one, the third one, almost the same, but there is a variation. Now here I have also z squared. So z squared equals x squared over a squared plus y squared over b squared. Okay, what is the graph? Okay, check the traces. Okay, if x equal to 0, or let me say if z is a constant, the trace هيكون x squared over a squared plus y squared over b squared equals a constant here, so it will be an ellipse. Okay, now if x equal to 0, you get z squared equals y squared, and if x equal to 0, you get z squared equals y squared over b squared. So this implies z equals plus or minus y over b. Okay, so you have 2 lines. The same thing, if y equal to 0, you get 2 lines. Okay, So I can 2 lines and an ellipse. The traces will be lines and ellipses. Okay. In fact, the graph will be the following. Okay, the graph. So we have something like this. We have these 2 lines, so they are going through the origin. So this is X and this is Y. Take 2 lines through the origin. These 2 lines also. Okay, 2 lines through the origin. Okay, now if there is a constant, you get an ellipse. So just to close this line with the ellipse, okay, with ellipses. Okay. The graph is good ايش؟ an elliptic cone, an elliptic cone, an elliptic cone. Okay. So it is ايش؟ an ice cream cone. Just one is opening upward and one opening each down. So it is a cone or an elliptic cone. Okay. So this is each the first three surfaces. Okay. Okay. Elliptic paraboloid, hyperbolic paraboloids, and an elliptic cone. Okay. These are the first three. Notice in all of them, the axis is here for the cone. The axis is the z-axis. The vertex is the origin. The vertex is the origin. Okay. So the cone is along the z-axis. Okay. Okay. So these are the first three. The next one, okay, 4. You have the following: x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. Well, this is familiar with you. Okay, notice هنا يعني if a and b and c are the same, you get a sphere. If they are different, you get something else. Okay, you get something like a sphere. Okay, in fact, we get an ellipsoid. Something like an ellipsoid. Okay, an ellipsoid. Okay. Well, notice the traces. What is the trace when x equal to 0? Okay, you get an ellipse. What is the trace in y when y equal to 0? You get an ellipse. When z equal to 0, you get an ellipse. Always the traces are ellipses. Okay, Okay. فهنا, if you want to graph it, really, find the intercept. And let me say, like graphing an ellipse in orientation, you just find the intercepts and then join them. The same thing here, to graph it, find the intercept and then join them. Okay, so this, let me do the following here. X, this is y, and this is z. And this is, okay. What is the x-intercept? You set y and z equal to 0. Okay, you get x plus minus a. So this is a, and this is minus a, minus. What is y-intercept? You set x and z 0. You get h, b, and minus b. So this is b, and this is minus b. What is the z-intercept? You set x and y 0. I call z equals c and minus c. So this is c, and this is minus c. Okay. Now, how to join this? Well, just in the xy plane, join a minus a, b minus a with an ellipse. So we get something like this. Okay. This is a minus a, and this is minus b. Okay. And also in the yz plane, the c's and b's, join them by an ellipse. You get something like this. Okay. Roughly speaking. Okay. So this is the graph in general. Okay, and without this, I could just, if you want to really graph it, just graph a horizontal ellipse, or let me say a vertical ellipse. So this is, let me say, something like this, and an ellipse in the middle, Okay, and then just make this. This is x, this is y, and this is z, and you put the intercept. Okay, This is an ellipsoid, so it is like a sphere, like a sphere. If A and B and if A and B and C are the same, equal, you get H as a sphere. Okay. If they are different, you get an ellipsoid. Okay. So this is the graph of the fourth one. Okay. In orientation, it is like the relation between a circle and an ellipse. Here in three-dimensional space, it is like a sphere, and the relation between a sphere and an ellipsoid. Okay. This is number 4. 5, you have the following. Okay. I will get the same equation, x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. Okay. So 5 is like 4. Okay. Okay. What about 6? 6 will be the following. The same thing here. 6 هيكون x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. Okay. So really the last three ellipsoid and the other two, the general equation is the same, but there is some variation. Okay. We make a variation on the equation of the ellipse. Okay. In number 5, we take this, the negative, the sign here at z, we work with it h negative. Okay. Okay. In number 6, we make 2 negative sign at the y and at the x. Okay. So here you have 1 negative sign and here you have 2 negative signs. Okay. What are we going to get? Okay. Notice the name. The name, you have to choose h. You have to check traces. Okay. Well, the trace will be the following. Okay. When z equal to 0, you get an ellipse. If x is a number or 0, you get h, a hyperbola. If y is a 0 or a number, you get h, a hyperbola also. So the traces will be h, hyperbolas and ellipses. Hyperbolas and ellipses. Okay. Now, let me see the graph here. Okay. So it is, okay. So this is, let me write هنا hyperbolas. So حتكون ايش the following؟ بقول لك ايش hyperboloids because the trace is hyperbola. When x equal to 0, hyperbola. When y equal to 0 is a hyperbola. It is hyperboloids of something. Let me see how to graph this one. To graph this one, the simplest way to graph this one, we take z equal to 0. Yani what is the graph? What is the trace in the xy plane? When z equal to 0, you get an ellipse. So I will just do the ellipse here. Okay. X, y, and z. Okay. It is an ellipse, which is the following. This is the ellipse in the plane. When z equal to 0, okay. It is an ellipse. Okay. Okay. What about the others? When x is a number or y is a number? If x is a number, حيكون hyperbola. If y is a number, hyperbola. Okay. So you get hyperbolas. So the hyperbolas, from this ellipse, I make the following. Make a hyperbola here and make a hyperbola here. Okay. Okay. Close them with ellipses. Okay. You get something like this. Okay. This is the graph. It is hyperboloid of. I will continue the name later on. This is the graph of this one. Okay. Just use the trace in the xy plane. It is an ellipse, and then an x equals 0 or a number, you get a hyperbola. Y equals 0 or a number, you get a hyperbola. Draw a hyperbola, then you close them with ellipses. Okay. Now for the next one, here, you have a negative. Okay. Again, what are the traces? Okay. If x equal to 0, that هيكون hyperbola minus positive hyperbola. If y equal to 0, again hyperbola, and a positive and a negative. A hyperbola. Okay. If z equal to 0, this is negative and this is positive. There is no trace. Yani there is no trace in the xy plane. There is no trace in the xy plane in z equal to 0. Okay. فإت is ايش؟ hyperbolas. فنكتب hyperboloids. Now, if z equal to 0, negative cannot equals 1. So there is no trace in the xy plane. There is no trace in the xy plane. But what about if z is a number? Okay, a large number, مثلا, then this will be a number. You take it to the other side, حيكون a number. You make, so if negative here and negative here, you can cancel the negative. You get an ellipse. You will get an ellipse. Okay. So the traces will be really hyperbolas and ellipses, but in the other floors other than the xy plane. Okay. So how to graph this one? Notice the following. Okay. Notice the following. Okay. So here you have the following. Okay. This is x and this is y and this is z. Okay. What is the trace in the xy plane? Z equal to 0. There is no trace. So nothing. There is no graph here. Okay. If you take other traces, حيكون hyperbolas. If y equal to 0 or x equal to 0 be hyperbolas. For a hyperbola, just draw any hyperbola. This is in fact not a hyperbola. There is no graph here. Take for z. Okay. Take intercept, z intercept. What is z intercept? You set x equal to 0 and y equal to 0, then z squared over c squared equals 1. So z squared equals c squared, and z equals plus minus c. So there is an z intercept at c here and at minus c here. Okay. Find the z intercept because there is no trace in the xy plane, so I just find that z intercept. Now the other traces are hyperbolas. Well, how to draw the hyperbola? You start from z, and just make a hyperbola. So this is a hyperbola here, and this is a hyperbola here. Okay. A hyperbola. Okay. If you take z as a number different from 0, for example, 10, 11, you get an ellipse. You get an ellipse. You close this with an ellipsis. You close this with ellipses. Okay. So this is the general graph. Okay. فكلاهما hyperboloids, they are close with the ellipses, but we say here the first number 5, it is one sheet, and 2 sheets or 2 pieces, and 1 piece, and 2 pieces, okay, separated. So the first one, you call it hyperboloids of 1 sheet, 1 sheet. The second one, hyperboloids of 2 sheets, 2 sheets, okay. 1 and 2. How to distinguish, how to remember which one is 1 and which one is 2? Well, if you have in the equation 1 negative sign, it will be 1 sheet. If you have 2 negative signs, you have 2 sheets. You have 2 sheets. Okay. But this is to distinguish the number of sheets. The number of sheets is equal to the number of negative signs. The number of negative sign. Now here, what is the axis? And the axis is the z-axis. كلاهما the axis is the z-axis. Okay. But notice هنا إنه really the axis goes with the negative, and the axis goes with the positive. يعني the axis goes with the number, with the variable associated with the less number of signs. I have 1 negative sign, 2 positive signs. So the axis will go with the z-axis. I have 2 negative signs and 1 positive sign. The less number of signs with z. So the axis will be the z-axis. Okay. You have to make some way to remember. Okay. So this is roughly speaking the general graph. And in all of these, I choose the axis to be the z-axis. Okay. So these are the basics. Ones. Okay. So let me now give you just simple examples here, just for example. Now, if you have z squared plus x squared, and we say here z squared equal 2x squared plus y squared. Okay. What is the graph of this one? Okay. So you have all of them, they are positive. Okay. So you need just to recall the basic, the previous 6, and compare. Of course, it is not 6, and it is not 5, and it is also not 4. It is number 3. Okay. You have z squared, x squared plus y squared. Okay. So it is an elliptic cone. an elliptic cone. So this is ايش what it is. Okay, we write an elliptic cone. An elliptic cone. Again, the axis is the z-axis. You have the following here. Just this is z, and this is x, and this is y, and it's just two lines along the origin, and you close them with an ellipse. Okay, close them with an ellipse. Okay. This is the cone. Okay. But this is the first one. Okay. So axis is the z-axis, vertex is the origin. Okay. What about the following? Z squared equals 2x squared plus y squared plus 1, for example. And now you cannot say just shift the cone 1 unit up, because in a z square it is not z. لو كانت z حتكون you can shift, but in a z square it is not true. Okay. So what do you do here? Again, compare with the previous graphs. They are all square, x square, y square, z square, okay, and you have a 1, so it is the last three, okay, just the last three, okay. Collect all terms in one side and see what you get, okay. Collect all terms in one side and خلي 1 in one side, okay. I will keep with the 1 in one side, so I will keep it. حتكون هنا minus 2x squared minus y squared plus z squared equals 1, okay. You have to keep 1 in one side and the others in one side, okay. Now you compare how many negative signs you have. I have 2 negative signs, okay. So it is a hyperboloid, of 2 sheets, The number of negative signs is the number of sheets. What is the axis? That is z-axis. Z-axis. Axis will go with the less number, and check the variable with less number of signs, okay. And you have z, have only 1, so I have 2 negative sign, 1 positive sign. 1, the positive sign, 1 goes with the z, so the axis is the z-axis of 2 sheets. If you want to graph it, just graph for 2 sheets, you just find the z-intercept. You set x equals 0, y equal to 0, حيكون z squared equals 1, so z equals plus minus 1. So you get something like this, okay. This is 1, and this is minus 1. Then you draw parabolas, 2 sheets, something like this, 1 and something like this. Hyperbola of two sheets. This is the graph, okay. Let me take a third one, okay, let me say x squared minus 3y squared plus z squared equals 1 or equals 3, let me say, okay. Well, what is the graph of this one? Okay. So you have a 3 square, and you have a number 3 here. If it is a 3 or 1 is the same thing. At the end, you need the general graph. هنا it is like 1. You can divide by 3 if you want, so this becomes x squared over 3 minus y squared plus z squared over 3 equals 1. Okay. And now you compare, you have only 1 negative sign, so it is hyperboloid of 1 sheet. 1 negative sign. هتكون hyperboloid of 1 sheet. Hyperboloid of 1 sheet. With 1 sheet. Axis, the y-axis. You have the number of positive signs, 2. Positive here. 1 number of negative sign, 1. Okay. And it goes. The axis will go with the less number of signs. Okay. And I have less number of signs negative with the y, so the axis will be y-axis. Okay. Well, to graph it, just you need only the general graph. So this is the y-axis here, and this is the x-axis, and this is the z-axis. So just take the y equal to 0. Okay. And in the xz plane, y equal to 0. Get an ellipse. This is an ellipse. This is in y equal to 0, y equal to 0, and then just make it ايش hyperbola. Okay, yes, hyperbola. Okay. And then just close with an ellipse, close with an ellipse. Okay, and this is ايش roughly speaking. Okay, always you need to know the form of the equation, the name, the axes, and a rough sketch. Of course, we didn't need exact sketch, a rough sketch. Okay, check the note. You have more examples there. And this is the completion of section 12.6. Okay. If you have any question about it, please come in the office hour and then ask about them. Okay.